We are hearing the term agentic AI everywhere. Like agents are going to replace human, or agents are going to become a tool. That is a separate discussion, but today we'll try to understand agentic AI, and this is the guarantee. Okay, if you understand AI agents, then only you'll be surviving in this job world, okay, in this IT world, right? So let's start with today's presentation. Okay, we have introduction to agentic AI. Okay, so earlier we used to have passive responses from the generative AI. Now, welcome to the autonomous world where AI agents can take action on your behalf. Now we'll try to understand what is agentic AI. Okay, so traditional AI systems were reactive, where whenever we try to, in case of generative AI, when we try to get some responses from the AI, they used to give us some response, okay, based on the data on which they were trained. Okay, but now agentic AI is able to take actions on your behalf. It depends on the defined goals, right? It is able to take decisions, okay, using some of the tools like for accessing APIs, for accessing databases, and like they are able to even trigger external services for you. They are able to plan the task. Whenever you give the requirement, they break it down into multiple subtasks, and one after another they are using one or more tools to take actions, and they are trying to like get towards your work towards your goals, right? So agentic AI simple definition will be the AI that can think, that can decide, and that can act towards a goal, right? So chat gpt was the, like earlier it used to be the traditional AI, generative AI, where they were only generating responses, but the AI agent is now able to do stuff for you. Let's suppose you ask for booking a flight. What it will do, it will use all the tools available to that particular AI agent. It will compare the prices, select the best option, and book the ticket for you, and even send you a confirmation email, right? So now, why do we need agents, right? Where is the issue, and what issue we are trying to solve with this? So basic LLMs were powerful. They were like giving us the code, okay? They were giving us the email. They were trying to give us a lot of content. Whatever we asked, they were able to give us the response, okay? But the real issue is, let's suppose we have teams who are trying to develop production software, okay? So this creates a gap between what AI knows and what it is able to do, right? So LLM limitations, it does not have the persistent memory, okay? Real world action capability is also not there, okay? And there is no native tool which the LLM can use, okay? And also multi-step reasoning chains are not available in case of LLMs. But the real world, now they want to automate complex multi-step workflows. Okay, there are, let's suppose, external APIs, they want to access them. If there are databases, we need to interact with the databases as and when required, and we need to trigger automation scripts on demand, make the decisions based on the live system data. Let's suppose you have written, or the AI, generative AI gave you something based on the earlier data, stale data, but now the system has changed, the live system has changed, and you want to the code or your data to be as per the live feed. Okay, so what you would do, you would require an agent to help you out in this situation. Okay, so for QA testers, how does it help the QA testers? Agents can now execute test cases autonomously, generate comprehensive reports also. Okay, they are able to even trigger Selenium scripts and analyze the failure logs. Depending on the failure, they can even modify your Selenium code. Okay, and all without manual intervention. All you need to do is to define the workflow, or to define the goal. What goal you need to achieve? If you define that well, okay, the AI agent will take care of everything else. Now, going further about AI agent, it is not only LLM. Okay, it decides what to do next based on the memory. Okay, so there should be one goal. That is the first and foremost thing. The goal should be clearly defined. Okay, and the brain for AI agent is the LLM. Whatever it thinks, it breaks down the task into subtasks. Okay, and then decides which tool to use. Everything is getting helped by the LLM. The tools are, you can think, if the LLM is the brain or the head of AI agent, then tools are the hands and legs of AI agent, using which it is trying to access external APIs, access external databases, on all those things. Okay, again, memory. Without memory, AI agents can behave like a short-term memory lost person. Okay, but if it has memory, it is able to remember the context. Let's suppose you talk to the agent once again after so many days, it will remember that you are that particular person, right? So memory is additional thing which an AI agent has. And again, action loop. Okay, so it is able to observe, think, act, and evaluate, and then again it is able to do this loop multiple times so that it is able to achieve the required goal, right? So agent is LLM plus tool plus memory plus decision loop, right? And now how AI agent works, agentic AI works, right? So we'll try to understand that. So we have the user goal. Okay, based on the user goal, the AI, agentic AI, it is trying to create a plan for you. Okay, based on the LLM. Then based on the tool, it is trying to do certain things, and then it is executing to achieve your goals, right? So this is the architecture which makes agent fundamentally different from one-shot prompts, which used to be the case when we had generative AI. So for an example, what we can do, check a website status and send report. What the agent will do, it will understand, it will, with the help of LLM, it will understand the user goal, and then agent calls the health check API, checks the HTTP responses, formats the finding into a summary, sends the report via email, all autonomously. And again, it is storing everything into the memory so that it has a context the next time we talk with the agent, right? So now types of AI agent. So we have multiple types of AI agents. We have simple agent where we just have the LLM, we do not have any tools, and it will be able to help you, right? Then we have the tool-based agent. Well, where like apart from the LLM or the brain, the agent has hands and legs as well, using which it can invoke external APIs, or like it is able to access external system, right? We have sequential agent. Let's suppose we have the workflow where we need to call tool A, then tool B, then tool C, then in the sequence, then it is called sequential agent. But many a times it is required for us to do multiple activities parallelly. So there we require parallel agents. Multi-agent systems are also there, where like we have multiple agents. Let's suppose you want to book a ticket, so you can have one travel planner agent, you can have one air flight ticket booking agent, you can have a hotel booking agent, and all these three agents will work synchronously to achieve the required goal. Now we'll try to see a simple agent example. Okay, so a simple example where we do not have any tools or memory, right? So the goal is generate test case for the login page. This is the goal. So what happens? Agent uses the LLM to reason about the edge cases and coverage. Okay, and then it will give you a structured output of all the test scenarios, and which is ready for execution, right? So this is the thing which will happen in a simple agent, right? So again, we are not calling any external tool. Okay, memory persistent is also not there, and the reasoning step is single, right? But that is not what we require in an agent. So we have tool based agent for our rescue, where we define the goal, okay, and based on the toolbox, let's suppose we have a Jenkins API, we have log analyzer, email sender, we can use all these tools to get to a specific goal, right? So in this example, if you see, what we need to do, we need to call external services, okay, and like get to a goal, right? So what we do, the agent is first of all, it is doing calling the Jenkins API, retrieve the latest build result and commit hash. Then it is trying to read the logs, okay. After reading the logs, it is trying to summarize with the help of brain, that is LLM, okay, and then it is sending the email report. So the goal of the agent is to check the latest build and then give us a report. So all of this is happening in multiple steps, 4 steps, and for each and every step, it is trying to use the tools like Jenkins API, log analyzer, and email sender. All these three are tools. Okay. Along with the tools, it is using the brain called LLM also to send us the report. After that, we are getting a very good, well formatted report, right? Now we'll try to see the multi-agent architecture. Okay, so here we have a test generator agent which will create test cases based on the requirement and the user stories. We have a test executor which will execute the generated test scripts, right? And then we have a report analyzer. Based on the test executions, we'll try to evaluate the result of the pattern and the flag the regressions, right? And we have a notification agent which will alert the team via Slack, email, or Jira ticket, right? So all these agents, let's suppose you give a requirement, we have a new functionality to test. The test generator will generate a test case for you, executor will execute the test case for you, the report analyzer will try to analyze the report, what kind of things went well and what went wrong, and accordingly it will notify to us via Slack, email, or Jira ticket creation, right? So this was the multi-agent architecture. Now again, we'll try to compare agentic AI versus traditional AI automation. Like let's suppose we need to create a flow. Okay, so the traditional AI will be fixed and predefined. The awareness will be hard-coded values. Reasoning won't be there. Failure handling depends how much failure handling you have done already. In case of new scenarios, it is going to break, right? Maintenance is also high. Based on each and every new functionality, you need to create the test case. At least you need to generate with the help of generative AI. But in case of AI agent, what is happening? It is dynamic, okay, context driven. It understands the system because it has tools. It is context aware and adaptive also. Okay, let's suppose you have a new functionality. Let's suppose it has a tool so that it can see your interface. It will adapt and generate new test cases, and it will try to test the functionality also for you. Okay, and it can reason about what to do next. It is adaptive and retries intelligently until and unless it reaches the predefined goal. And the maintenance is lower, okay, because it learns from context. So all these functionalities are there. Okay, so let's suppose we have this example: execute predefined steps in order. If the UI changes or element is missing, the script fails and requires manual intervention. This was the case when we had generative AI. Till generative AI, this was our solution, like situation. But now with the advent of AI agents, AI agent will decide which test to run based on the recent code changes, and it will adapt when the elements shift. Okay, we do not need to manually change or like use again generative AI for generating the test case again. The AI agent will take care of changing the elements, right? It retries with alternative strategies and reports the root causes and not just failure, right? It is able to understand. Now, for automation tester, how we can learn. Okay, so first of all, we should understand the agent loop. Okay, how it is able to observe, okay, understand your requirement, think and act, and like get to the result, right? So you can try to build a simple agent, okay, for any simple task that will not use any tool. Okay, so after that, try to add some tools to the agent so that you can do specific tasks using the tools. You can start adding memory also, so that the agent has context every time when we switch back to the agent after a long time. Okay, you can try building sequential agent, okay, where you know the sequence of tasks. Let's suppose you have some tasks which should be executed parallelly, so you can try to create some parallel agents, and then try to integrate with Selenium, so that like based on any new functionality, you can see how the agent is reacting, okay, how it is creating the test cases by itself, and it is able to uh, plan for the execution, and also observing, okay, it is able to observe the execution. And the deployment is the main thing. When you have created the agent, it should be deployed somewhere, so that in the production system also it is able to do all the things independently, right? And finally, like our end goal is to become a AI powered QA assistant. Okay, the ultimate destination journey is for a fully automated QA assistant. We need to create this where the agent can think, decide, and act according to the situation. And the future of QA is not about writing more script. Okay, it is about building the agent that tests smarter, and that will be your role in the future going forward. And the future is not far away. Okay, in the next 3 months to 6 months, you'll be able to see that QA testers are not writing scripts anymore. Okay, they'll be writing the actual workflows where the agents will interact among themselves, use the tools to get the required functionality. And that was the video, guys. If you find that this was useful for you, please press the like button, and also subscribe to Akansha Academy for more such videos. Thank you so much. We'll be back with another video.